our job today is to finish hydrostatic forces. I'm going to do mostly triangles and one half circle. And there are a couple of little idiosyncrasies that you'll see as we go through them. And that is that there is more than one way in which to set up your picture that's going to allow you to calculate the hydrostatic forces. The final answer is the same, but the way in which you set it up, there are actually three ways you can set them up. And that doesn't normally cause a problem because you're going to get the right answer. And if they only want the answer, you will never know that the solution that they did in the WebAssign was a different version than yours. Good chance it's the same, but it could be different. The only difference is that there are some questions where you just set up the integral and you fill in the missing gaps. And in those questions, they're only accepting one of the methods. And that would be fine if they stuck to the same method each time. But they don't. So that's where the idiosyncrasy is going to come. So the way I'm going to fix that is all the questions that have a set up integral part, I'm making sure I'm doing those. So you can see the version of what they did. And hopefully that'll make it easier. It would be nice if WebAssign just allowed you to put in any of the three ways you can do it, because they all work, right? And they all basically do the same job. That's why they work. And then it wouldn't be a problem. I could just say, write down whatever version you feel like. But before we do that, let's do number 13. And I'll do that thing that Matthew suggested. I'll go out and in for a second. Nobody here? Okay, so in this particular situation, there's probably only one sensible way to do it. So I won't show you any of the other two. But it's on the surface, the tip is anyway. Goes something like that. And the distance from the top to the strip is called the depth. And in this situation, I'm going to call that X as well. And the distance from here to here is going to be called W. And we know from previous questions that we need to find out what the depth is in terms of X and what W, the width, is in terms of X. Okay, so if the distance from there to there is the depth, and I'm calling that X, then there you go. And I just got somebody. Now, to get the width, we build similar triangles. And in this picture, the big one is 5 meters and 4 meters. And the little guy is X and W. So this is a pretty standard question. So X over 4 equals X over 5, I apologize, corresponding values, W over 4, which gives you 5W equals 4X, which gives you W equals 4/5 X. Are we good with that? So what you're looking at now is pretty much everything that you need. It's going to be the integral from A to B of delta the width, the depth, and the x. I'll stick delta on the outside. The width is this guy, the depth is that guy, so 4/5 x times x dx. And the only other thing we're left with is the a and the b. A is the value of x that you would get at the top of the triangle, and b is the value of x that you would need to get to the bottom. In this case, since it's right on the surface, and x is the distance from the surface, won't a be 0 and b be 5? And that becomes the integral from 0 to 5 of 4/5 x squared dx. And at this point, I'll dot, dot, dot. Are you comfortable with that setup? It's a pretty standard one, nothing too weird going on. And you know how you finish that, isn't it? Just a power rule with some ugly fractions in it. Right. Here we go. Right. That's really the only sensible, well, sensible's a bad choice. That's the most efficient way to do this. I said there's two other methods, but in this case, I'm not showing you because I'll keep it for a question where there's a kind of moral, logical choice that could happen. This is question 16. And this question is one of those ones where you are going to, oh, almost forgot. In this question, since it's metric, won't this fella be that magic number? Right, when it's metric meters, that's what delta will be. Almost forgot that. Okay, this is question 16. And question 16 has a triangle not unlike the one we just did. Looks like that. What's special about this particular triangle? Nothing too much, just filling in some more numbers. I think the main difference is, isn't it, it's below the surface. So I'm going to show you two ways to do this question. Now, the way I would typically do it, and the way I've been showing you, is that we'll call x the difference, the distance from the top of the shape to the strip. Right, that's how I would do it. And that's going to be version 1. And we are going to find depth and width, which is that guy, in terms of x. So I would construct my little baby triangle. And this distance would be x, and this distance would be w. And then I'd have the big, similar shaped triangle, and it would be using the numbers, even though it's not to scale, 2 and 6. So x over 2 is equal to w over 6. So 2w equals 6x. So that makes w 3x. What expression will we use for the depth in the way that I've just done this?
X plus x.
Agreed. So to get the hydrostatic force, it's going to be the integral from A to B of delta. The width times the depth dx, which is there's delta. Width is going to be 3x. Depth is going to be x odd 6 dx. Now, in this question, isn't A the x that gets you the top of the shape, and B the value of x that gets you the bottom of the shape? And in this case, x would be 0 and finish at 2. Are we cool with that? Now that makes the hydrostatic force, there's going to be a delta somewhere, I'll stick it out here, 3x squared plus 18x dx. And that is the answer that you will be typing in, because this is one of these fill in what it would look like as an integral question. So that is the way that they did it. It has a number, and its number is about 400. This, in my case anyway, it's about that number, right? But I guess it depends on, you know, everybody gets a slightly different version. Maybe that's 3, maybe that's 7, maybe that's 2. But for the numbers I've got, that's what that would become. Right, we go with this one. Now, that's the way I do it, and that's the way the textbook did it. And I thought, hey, not a problem. Until I saw a later question. But I'm not going to show you that later question yet. I'm going to show you a second way of doing the same question. And it looks like this. We know that distance there, right, from the surface to the strip W. We know that distance is called the depth. But they call the depth x. Now that's going to cause some problems. Because when I do my little triangles, that's fine. I have to figure out what that distance from there to there is in terms of x.
X minus 6.
So when I do the matchup, it's going to be x minus 6 over 6 equals w over 2. So 6w will be 2x take away 12. So w will be 1/3 x take away 2. When you compare the depth and the width, do you see that they're now different? And I put a w there by mistake, sorry.
Wouldn't the 6 or x minus 6 be over 2?
Would the x minus 6 be over 2? Well, when you do cross multiply, you multiply, so it'd be 2 times the number.
You know, when we're comparing the similar triangles, because isn't the x minus 6 like the height of the smaller one?
No, the height of the smaller one's the difference from the top to the bottom. The height of the smaller one is x take away 6.
Yeah, so then wouldn't that be over 2?
Y over 2.
I
Oh, you
just
mean
thought,
compare? Oh, darn it in space. I know what you're saying. I'm just not listening. Yes, you are right. X minus 6 matches with 2. That's what you're telling me, and I just wasn't paying attention. So 2W is 6x take away 6. So W is 3x take away 3. It's still different, but a different kind of different. Now, when you set it up this way, then the hydrostatic force is going to be the integral from A to B, delta, width, times depth.
and it'd be 3x minus 18.
Oh God, I am not on. I'm too busy trying to get to this bit, and my brain is not focusing enough. Delta 3x take away 18 x dx. If I pull out the delta, see if I can get this bit right. We get that guy. Now, the x. What's the value of x at the top of the shape, and what's the value of x that gives you the bottom of that shape? Well, since x is measured from the surface, won't A be 6 and won't B be 8? That integral is the same as this one here. It will also be 431,200, but can you see it's a little bit different looking? Now, I said there's 3 ways of doing this one. 3. This one I'm only going to partially set up. You might have thought I have figured out, or I have used every possible way of looking at this picture. Well, I haven't. Here's the last way. We'll call the distance from the bottom of the shape to there x. Let's figure out what the depth and the width would be in this case. This distance is the depth. This distance here is x. The total distance from here to here is 6 add 2, which is 8. Does it not make the depth then 8 take away x? If you build your little triangles, this guy's W, this guy's 6, this guy's still 2. And now I have the problem of this fella. Well, if this piece is x and the whole thing is 2, won't this fella be 2 take away x? So if you match corresponding sides, one of these is not right. There we go. you get, let's try that again, 2 minus x over 2 w over 6. There we go. So 2w is 12 take away 6x. That makes w 6 take away 3x. Right, I'll dot that. Can you see that each method will eventually work, right? Each method will eventually give you the correct answer. Would you also agree that at least one of them was a lot less work than the others? Now, I don't know why the textbook managed to choose this method and then this method for some of their later questions, but evidently they did. So if you wonder as I'm going through these why I keep changing the process, it's just to get you so you can set up the integral versions, right? You know, the ones that say, fill in the missing pieces of this integral puzzle, right? If it's a question that just says find the thing, I'll just do my first method all the time, right? I'll just do one method. So let's move on. What have we got next? We've got 15. 15 is one of those fill in the missing integral ones. It's got some water, and on the surface, there's an equilateral triangle. And this equilateral triangle is 4. So we're going to have to figure out a strategy for getting this guy. I'll take my horizontal strip, call that W. The distance from the surface to that horizontal strip is going to be the depth. And this is the easy bit. Since it's on the surface, won't the depth be x? Go on. Come on. Let's go. Shoot. That was Maggie. She was, I don't know what she wanted. You could hear my little dog. Right, now we need to get the width. This is not quite like anything we've done so far. Do you notice that the 4 is not a vertical distance, it's the sloping sides. So I am not going to use similar triangles. I am not going to use similar triangles to get the value of W.
Agree.
Agreed? So what we need to do is we're going to use Pythagoras. So I'm doing a slightly bigger version of that. I want you to imagine you cut the shape vertically downwards. I can do that. And if you look at your strip, this piece here is the exact same size as that piece. Would you agree? Mm-hmm. Now, since the whole thing is W, won't this piece be a half W? Right. Now, actually, I take this back. I am going to use 4. This distance from here to here is going to be x. So that makes this distance from here to here oh, I need to get Pythagoras. If this distance here is 4, that guy there is 2, won't this vertical distance be the square root of 12? So I did have to use my Pythagoras. Right? 2 by 4 by square root of 12. 16 take away 4 is where that came from. Now, I need to know this distance here because my little baby right angle triangle is going to be 1/2 W, this number, and the big triangle is going to be 2 square root of 12. So this one makes it a little bit different. So I need to know that number. Now, this distance is root 12. This piece here is x. So the guy I want is the total distance take away x. So root 12 take away x. So this guy with this guy. So root 12 take away x over root 12 is going to be equal to 1/2 W over 2. Bit messy, but we should be able to do that. 1/2 root 12 W is going to be 2 root 12 take away 2x. Oh, let's do this in 2 stages because I'll screw up otherwise. If you multiply both sides by 2, you get that. If you then divide everybody by root 12, you get that. Right, the rest is just making it pretty. Is there a way that 4 over root 12 can be made to look a little bit nicer? Four over root 12.
You could take a 2 out of the radical.
And that's what they do. So we now have the 2 pieces that we need. So it was a little bit different, right? Because of the basic information. Now you put that package together, then it's going to be the integral of delta, which I'll stick outside, and you're going to go depth and width. So essentially you're going to take this guy, multiplying by that guy. So far, so good. Now, A is the value of x at the top of the shape, which is 0, and won't B be the vertical value at the bottom, which is root 12. And that's the thing that you fill in. Now, if I'd chosen to do any of the other 2 techniques that we showed you today, you would end up with a different looking integral and it would have said you were wrong. So this one, I think that's a natural one, so I'm kind of happy that it would do it the way I would do it. Any questions about that one?
Yeah. So in the big triangle, you have root 12 minus x. Which line are you calling that?
This one here is him. So it's a half.
So the whole length you're calling x? No, the whole length is root 12, and then you're calling the upper part x.
Correct.
Okay, thank you.
So that entire distance from there to there is root 12. This piece is x, so this piece is y. This piece is root 12 take x. Are we good? Okay, let me go out and check if nobody's turned up late again. Nobody. Okay. So I'm going to put a mute all, getting some background sound. There we go. We comfortable with that one? Okay. I think we've done that one, yeah. Oh, the half circle. You've all been looking forward to the half circle, right? Okay. Here's the water surface. Half circle.
We can't
what
see your
it is.
screen.
God, you lot are pushy. Hey, I could see the screen. That's really all that I was concerned about, right? Okay. So this hemispherical plate, which is a half circle plate, has a diameter of 6. So I'm going to write this down. Which means that the distance from there to there then is 6. And I believe it's in meters. No, it's feet. And what else do we know? We know it is 1 foot below the surface. All right, this one is a challenge. And it's also one of those questions where they use, you have to fill in what the integral looks like. And they use one of the other 2 techniques that we showed you today to do it. So if you did it the way I would typically approach it, it doesn't work. And just for added fun, they changed the letter to y. For no good reason. They could have kept it as x. Every other blinking question is x. But if they're going to confuse you, they might as well stick in a new letter just to add to it, right? So the setup is going to be exactly the same. At least at the beginning. And won't this distance be called depth? Agreed? Now, there's a hidden number in here. What's the distance from the top of that to the bottom of that?
3.
Now, this particular question does use Pythagoras, but it only uses Pythagoras. And, oh, there's my W. Would you agree right now it doesn't look any different from the usual setup? And it isn't. It's going to get different quite soon. And that is, who do we call? Well, I used to say, who do we call X? But now it's going to be, who do we call Y? Now, the most natural thing would be to call that distance Y. Agreed? That's what I typically do. But didn't one of the other methods I showed you today says that you can use that guy and call him y? And that's actually going to be the start. Now, if this distance is y, I need some more squiggly lines. What number is it from the surface to here?
Four.
Great. Now, if this is 4 and that is y, what will the depth be in terms of y?
4 minus y.
Would you agree that's making it uglier rather than prettier? Wouldn't it be much easier just to call it, the top-down distance? But there's a kind of logic behind this. Now what I'm going to do is I'm going to draw a vertical line straight through the center of that shape, which means this guy is now a half W and this guy is a half W. Are you comfortable with this piece here? Just the piece on the right-hand side is half a W. Right. Vertically, you cut it into 2 equal pieces. Now, if I take this picture and I add an extra line going that way, and I draw another line coming down that way, and I do a third line across the way, do you see a right angle triangle there? Now let me draw it separate because there's so much other stuff. Imagine this guy is this guy. Isn't that guy a half W? Isn't this guy y? What's this guy? And he's a number. What's this
3.
distance? Because isn't he another radius of that circle? Right, any distance from the center to any point is a radius. Now, this picture allows me to figure out what W is in terms of y. And that means I'll be able to get the width then, won't I? Okay. Now, according to Pythagoras, isn't 3 squared y squared plus a half W squared, right? So 9 is y squared plus 1/4 W squared. And what do we do now? Well, 9 take away y squared is 1/4 W squared. So far, so good. Okay, what would I do for the next line? What would I do to both sides to get it a little bit simpler?
Multiply it by 4.
Okay. Now, normally I would actually do the multiplication. I would say 36 take away 4y squared, but I'm actually going to leave it like that. Because can't I now take the square root? And what do I get? I get 2 the square root of 9 take away y squared. So I have a depth and I have a width now, don't I? So I should be able to get the hydrostatic force part. It's going to be the integral from A to B of width, depth, dy. And I forgot my delta. So it's going to be delta times 2 lots of this fella times this fella dy. And they bring out the 2 in the delta in the question. And you're left with, oh. All we have now is the value of y. And it's from the top of the shape to the bottom of the shape, right? Here to here. Y equals 0 to y equals 3. At the bottom of the shape, won't y be 0? And when you get to the top of the shape, won't y be 3? And that's the ugly guy that you fill in 17. And what does he equal? Well, they gave us a clue here. If you have a question that says round me off to the nearest whole number, what technique do you think you're going to use to get the answer?
Calculator.
Yeah. So you don't need to worry about spending half an hour trying to figure out some really cool U subs followed by some X subs and a whole load of really cool math. Because if they only want the answer to the nearest whole number, won't the calculator do that for you?